Okay, so first section we're going to take a look at is 1.1. It talks about lots of different topics you'd study in Algebra 1, from like a number line to the XY axes, absolute value, I think like shading on a number line, like an open circle, closed circle. So it's lots of review topics. So I don't think you'll find most of this new, but we'll go through it and make sure everyone's on the same page. So first thing they talk about in the section 1.1 is this number system diagram. So basically what I've drawn here is how you can classify numbers, starting with the simplest numbers on the inside, working your way out to more complicated numbers. So the simplest kind of numbers that you can have are counting numbers. Counting numbers start with 1 and go up. They don't have fractions, they don't have decimals. 1, 2, 3, 4, 5, 6, 7, 8. Those are counting numbers. The problem with just using counting numbers and not having any other type of number in math at all is that when we do arithmetic, we can run into problems where we get answers that are not counting numbers. There are other kinds of numbers besides counting numbers. It wouldn't happen with addition. Okay, if you give me, well actually I'll ask you guys, Francesca, can you give me a counting number?
7?
7? You sure?
No.
No, 7's good.
I'm not sure, but yeah.
So 7's a counting number. Matt, can you give me another counting number?
2.
2? And if we add these together, we get a counting number. Does everyone agree 9 is a counting number? That is something special, which I'll talk about the word for later on. But if you start with a counting number, you do an operation, you use another counting number, and the answer that you get is a counting number, that means something. Let's try this. Just 2 minus 2. Is 2 minus 2 a counting number? What do you think? Ashley?
No.
No, that's not a counting number. And there's a name for that. The fact that you started with a counting number, you subtracted a counting number, but the answer is not a counting number. It's outside the counting number set. So what we have now is a problem. If all we know is counting numbers, there's no way to do that problem. So we have to invent a number that's not a counting number that represents the answer to this problem. And that's where we have whole numbers. Okay, so whole numbers include 0. So it extends what you can do with arithmetic a little bit more than just counting numbers. Whole numbers are definitely used in everyday life. You can have $5 and spend it all and you're left with none. As an example, right? You're left with 0. Okay, so that solves that problem, but we could still have another problem. Let's say you had 3 and you subtract 5. If I showed that to somebody in like 1st or 2nd grade, they'd probably look at it and say, I've never seen subtraction where the bigger number is at the end. Usually the bigger number is first. Because how can you take away more than you even have? Well, you can't if you're dealing with whole numbers. We know that you can take away more than you have, and when you do that, you get a negative number, and that's where integers come in. Okay, so integers now include positives, negatives, and 0. As far as addition or subtraction, you could name any integer, and I can add or subtract any other integer, and I will get an integer for the answer, always. But we could run into a problem with another operation. Can anybody think of something in basic arithmetic we can do where we have an integer, we have another integer, and whatever we do to the two of them, the answer is not an integer anymore? Have a guess? Yeah, Jake?
Division.
Division. We could run into a problem. This is fine. That's an integer. That's an integer. When I divide them, I get 2, which is an integer. 2 is also a whole number. 2 is also a counting number. Right? But can you give me an example, Jake, of a division problem where you start with an integer, you have another integer, but you don't get an integer for the answer?
4 divided by 5.
4 divided by 5. Okay, that's a problem with integers. Okay, if all you know is integers, you can't do that. There's no way to take 4 objects and divide them out to 5 people. The only way you can take 4 and divide it out to 5 is if you start breaking things into parts or fractions, pieces of things. And that's where rational numbers come in. Right? So rational numbers are numbers that you can write as fractions. And I think those are still pretty common in everyday life. Right? You might, if you're cooking something, maybe you don't need 2 cups of flour or 3 cups of flour, but you need something in the middle, like 1.5 or 1 1/3 cups. If you buy something at a store, most of the time when you buy something, it might cost in between dollar amounts. It might not be $20, might not be $21, might be $20.50, right? Somewhere in the middle. So that 50 cents, that's a 0.5, that's a fractional part of a dollar. So rational numbers are all the numbers we can write as fractions. If rational numbers are numbers we can write as fractions, then this box over here are numbers that you cannot write as fractions. Irrational numbers are not used as much in kind of everyday math, but can anybody think of a number that you can't write as a fraction? Yep.
Pi.
So pi is a number that we can't write as a fraction. Square roots. I don't mean like the square root of 4 or the square root of 9. That comes out nice. But the square root of 3 doesn't. And even for everyday purposes, even if you're running like a CNC machine, and maybe you're doing something with a circle, you're going to have to use pi. But you're probably not going to use thousands of digits of pi. The machine you're working on is only so accurate. Right? Maybe it's accurate to the thousandths, the 10,000ths, 100,000ths of an inch. You know, I don't think it's millionth. So I'm probably not going to get much more accurate than that. So for everyday practical purposes, even a number that you can't write as a fraction, you're going to have to round it off somewhere if you want to use it. Maybe 6 decimal places, maybe 7. I don't know. It depends on what you need. But you're going to have to round it eventually. Right? But pi is a number that you can't write as a fraction. And if you take all the numbers that you can and cannot write as fractions, that's called the real number system. And those are the numbers that we're going to stick with through chapter 1. There are numbers beyond the real number system. We study those in algebra 2. Those are your imaginary numbers. But we're not going to get into those right now. Now, just to kind of make this diagram kind of make sense, I usually compare it to like places, starting with a small place and getting to a bigger place. So think of this middle box as Boston, and then think of whole numbers as Massachusetts, and then the Northeast, and then the United States. If you are in Massachusetts, are you automatically in the Northeast? Is that true? Yeah. You're in Massachusetts, you're in the Northeast. So in other words, if you're a whole number, you're automatically within the integers as well. But if you're in the Northeast, are you automatically in Massachusetts? No, it doesn't work that way. Just because you're an integer doesn't mean you're automatically a whole number. If you're in Boston, then you're automatically in Massachusetts. If you're in Massachusetts, you're automatically in the United States. So if you're in an inner box, you're automatically in the outer boxes as well. Okay, any questions on that? So there are some symbols that we use when we talk about some of these number systems. Okay, a couple of them I think I can explain. This capital looking R kind of thing. R stands for the real number system. We use a Q for rational. We can't use an R again because we already used that. Anyone have a guess where the Q might come from? Can you think of something you do with division and a word comes up that begins with a Q?
Quotient.
Quotient. So my guess is that's where the Q would come from, having to do with quotients. The Z for integers, I don't know. I'm not sure why they use Z. So those might be different symbols you see me use when I'm talking about different sets of numbers. Now, what do you think this means if I did that? I'm not just talking about integers anymore. I'm talking about something a little more specific. I have a guess? Yeah, Jake?
Would it be positive integers?
Yeah, I'm looking specifically now for a positive integer versus a negative integer. Right? So you can add that to the symbol as well to denote something more specific, like positive or negative. If you don't put a symbol, it means all of them. Okay, questions on that? So in math, there are 4 basic arithmetic operations that we call binary operations. So the prefix on the word binary means 2. Means 2. In other words, to do addition, subtraction, multiplication, and division, you have to tell me 2 numbers. If you said, I want you to add the following, 3, and that's all you told me. Well, I can't do that. Okay, you want me to add 3, and what's the other number you want me to add? You have to tell me 2 of them. Compared to an operation like this, square root doesn't take 2 numbers, it only takes 1. If you want me to do a square root, you only have to tell me 1 number. Okay, that's different. So we're going to look at some properties that involve some addition and some multiplication, and we're going to just write down some names. Okay, you've seen a lot of these properties, I think, before. There's one of them that I mentioned earlier. If you start with a counting number and you do something to it, and your answer is a counting number, there's a name for that. Basically, the answer that you're getting is staying within the box that you started. If it goes outside the box, I'll tell you what that's called. And that's going to be the first property we take a look at. Now, to describe the properties, I'm going to use letters, variables, and these variables can represent any real number. So that property, or that idea that if you start in a box and your answer is in the same box you started with, that is called closure. And closure is true for real numbers when you add them. You can name any real number you want. Somebody else could name another real number. I can add them together, and the answer will be a real number. In fact, when you do addition, the addition property is closed. That's what closure means. The addition property is closed for every number set. If you add an integer to an integer, you get an integer. If you add a counting number to a counting number, you will get a counting number. Doesn't work for subtraction all the time. And I showed you that. You could give me a counting number, give me a counting number, and the answer is not a counting number. It doesn't stay within the box of numbers you started in. It goes outside it. That means subtraction doesn't obey this property. For counting numbers. Does it for real numbers? Absolutely. Pretty much everything you do with real numbers, the answer is a real number, because real numbers is like the biggest box you can have. Everything is within that box for chapter 1. All right, how about, let me show you a property name and see if you can tell me what it is. It says A plus B is the same as B plus A. It has to do with changing order, like 5 plus 2, 2 plus 5. Does anybody remember what property that is? I'll give you a hint. People that go to work, what do they call their drive in the morning? Yeah?
Commutative.
Commutative. Commute means to go from one place to the other. Things move back and forth. That's the commutative property of addition. There's also a commutative property of multiplication. I'm not going to write that one down. It's in your book. But the point is, you can add two numbers in any order you want. All right. The next one. The next one has to do with how you group things. The order is the same. ABC, ABC. But it's what you're doing first. Anybody remember what this property is called? You usually study it with commutative at the same time. I'll give you a hint. Remember, these are grouping symbols. And if you think of the B and the C, they're grouped together. And if you think of like a group of friends, you would say, well, those are the people that I blank. That's the word I'm trying to tell you. The people that you regularly talk to, the people that you hang out with, the people that you, yeah?
Associative property.
Associative. Right? Associative has to do with group. Right? So if you said, those are the people that I associate with, those are the people you hang out with. It's like your group. Parentheses are a grouping symbol. Brackets are a grouping symbol. Even the fraction bar, that's a grouping symbol. You see something like that, fraction bar means do the top first, do the bottom second. Okay. This next one, a little bit tricky, but that's called the identity property. For addition, the identity property means you do something to a number and you get the same number back. So for addition, that means add 0. What would it be for multiplication? It wouldn't be multiplied by 0. That wouldn't give you the same number back. Chris?
You multiply by 1.
Multiply by 1. Okay, that's the addition property, but that's the identity property. X times 1 equals X. That's for multiplication. This next one is called the inverse property. For addition, the inverse property is what can you do to a number to get 0? And what can you do to a number with addition to get 0? You can always add the opposite of the number to it. Adding a number and its opposite gives you 0. How about this one? This is one that usually more people recognize. I think they know the name of that next one. It's one we use it the term more often. Sarah? That's the distributive property. So you're multiplying something on the outside to something on the inside. You can do it with addition or subtraction. You definitely would not do distributive property in that situation. You do not do a times x and then a times y. No. Just so. If you look at page 7, I think it's page 2, I'm sorry. If you look at page 2 in your book, it has some of these other properties listed for multiplication. Okay, any questions on those properties? Okay, and we'll do an example in a minute with them. All right, so there's 3 other properties I want to mention, but these properties that I'm going to mention apply to an equation. This is not an equation, 2 minus 5. That's an expression, a numeric expression. What's missing from 2 minus 5 to make it an equation? What does an equation have to have? Jack?
The equal sign?
Yeah, it's got to have an equal sign. And even more, that still wouldn't be an equation. What else do you need? 2 minus 5 equals, it's kind of like wants to be an equation, but it's not. Yep. Yeah, you need something on the other side. It can be a number, could be a letter, But to make something an equation, you have to have an equality symbol between two expressions. These all have equality symbols, and there are expressions on each side. Could be an algebraic expression, could just be a numeric expression. These are all equations. Whether they're true or not, that's different, but they are all equations. This first one, 2x equals 12, we call that a conditional equation. It could be true. There's a condition to make it true. You have to pick the right value for x. This other one on the right, 5 equals 2, that's a contradiction. That's an equation that is never true. And you might wonder, well, how could you end up with something like that? Well, you could have this. If I gave that as a problem in Algebra 1 to solve it, the first thing most people would do is subtract 2x from both sides, and then you're left with 5 equals 2. And you're done, which means the equation has no solution, because that's a contradiction. And then this last one is an identity. 3 plus 4 equals 2 plus 5. That's 7 equals 7. So that's an equation that's always true. So, could be true, never true, always true. All right, so the last three properties I'm going to mention have to do specifically with equations. And the first one is called the reflexive property. The reflexive property says that something is always equal to itself. Most of the time, you see that property when you're doing a proof. If you had two triangles and you're trying to prove maybe that they're congruent, maybe you're trying to prove triangle ABC and ACD are congruent. Well, you could say that side AC is equal to itself because side AC is shared in triangle 1 and triangle 2. That's the reflexive property. Something equals itself. The symmetric property says if A equals B, then B equals A. It's like saying if x equals 5, 5 equals x. It's the same thing. What the symmetric property allows you to do is take what's on one side of the equation and switch it completely with what's on the other side. That's not the commutative. The commutative lets you switch two things on the same side. The symmetric property lets you completely take the left side and make it the right, and the right side and make it the left. And the last property that we talk about with equations, that's called the transitive property. When I see transitive, I think of that as like a chain of things. So A equals B and B equals C, then A equals C. It's kind of like if I said, all right, if you do your homework on Monday, then you won't get homework on Tuesday. And if you don't get homework on Tuesday, then you won't have a test on Friday. So basically, if you do your homework on Monday, then you don't have a test on Friday. That'd be an example of transitive kind of argument. That's not true, though. Just an example. Okay, so any question on those three? Let's try an example. So in this example, I've given you an equation, and I want you to prove to me that what's on the left is the same as what's on the right. To prove that they're the same, they should look the same. Right now they don't look the same. I I got a 2, and I got parentheses, and I got a 3. I don't even have a 3 on the other side. So we want to show that they're the same. So what I'm doing is I'm giving you the names of properties that I want you to use. All you have to do is write down the step for the property. So let's start with distributive property. How about Abigail? What side of the equation here uses distributive property? Which side? The left, yeah. So left side is where we're going to do some distributive. So we're going to keep the right side exactly the same for now. And Jack, can you tell me how do you do distributive? Like what do you have to do?
Multiply the 2 by x plus 3.
And so I'm going to multiply the 2 by what first?
X.
So I'm just going to leave it. It's 2 times x. And what else did you say to multiply by?
2 times 3.
2 times 3. To do a distributive property, that's all you have to do. That's the distributive property. Now the next step is to simplify. Casey, can you simplify what I have up above there? So I just want to simplify anything that I can simplify right there.
2x plus 6.
So we're going to have 2x plus 6. And now the last step would be the commutative property. Isaac, which side can I apply the commutative property to so that both sides look identical?
The left side?
Yeah, the left, or you could do the right, right? Either way, but the commutative property lets you switch the order you add two things. Isaac said the left, so let's do it the way it's on the left. Make it 6 plus 2x. And the right side is 6 plus 2x. Right, so we showed that the left and the right hand side are the same using some of the properties that we just learned. Now, the other way I could give you this problem would be like this. Give you all the steps and say, what step, how did I get from here to here? What did I do? I did distributive property. Right? So I'll either give you the work and you'll tell me the name of the step, or I'll give you the name of the step and you'll show me the work. That's how you could see a question like that. Okay. Any questions on that? All right. So now we're going to move into lots of little review topics. So first thing is a coordinate system, not even a double coordinate, not even an x and a y axis yet, just a single number line. On the number line, 0, we call that the origin. Positive numbers go right, negative numbers go left. Now, once we have number lines, we can do things like this. We can mark the number 2. We can mark the number 3. Because the number 2 is to the left of the number 3, that means something about it when you compare the number 2 to the number 3. What does that mean if a number is to the left of a number on a number line? Yeah?
That it's less than the number to the right.
Yeah, it's less, right? Numbers to the left of a spot are smaller. Numbers to the right of a spot are larger. That's called giving order to numbers. And we have 4 symbols that we can use when we're comparing numbers. Less than, greater than, less than or equal to, greater than or equal to. Does anyone remember what these 4 symbols are called? It begins with an I. There's a name for these group of symbols. Anyone remember what it is? So what does this symbol mean? Equal or equality? These are the opposite of equal. Inequality. Smaller, larger, smaller than or equal to. Okay, those are inequalities. So we'll talk a little bit about when we're graphing on a number line, how do we do it? Okay. Like if I wanted you to graph x is less than or equal to 5. Well, I'll show you how to do that. So there are two kinds of marks. When we want to mark the number that we're going to graph, there's two kinds of circles we can use. Does anyone remember the names of the two options we have for circles? Yeah.
There's like a filled circle and then there's like the hollow circle.
Yeah. It's either a filled in circle or you don't fill it in. Do you remember when you use a filled in circle versus the open circle?
Yeah.
Yep.
Isn't a filled in circle when it's greater than or equal to or less than or equal to?
Yeah. You use a filled in circle, you call it a closed circle, when you have the equal to. So the way I remember it is the symbol has an extra thing in it. Right? It's got this extra line on the bottom, so you have to take the extra step and fill the circle in. When you have just a greater than or a less than, we're going to use an open circle. Now there is another way to do it besides the open and the closed circle. I'll touch on that quickly because our book uses that. But when we do it on a test, like an edge elastic, this is how it's going to be set up. All right, well, let's try an example of graphing an inequality on a number line. These two problems are exactly the same. This is the way we prefer it. Because if you do it the way that's on the left, the symbol tells you the direction to shade. So as long as you set it up so it's letter, symbol, number, the symbol will point in the direction to shade. If it's not set up, letter, symbol, number, this one on the right, then this will not tell you the direction to shade. In fact, it'll tell you the opposite way to shade. So whenever we write an inequality, let's try to stick with that pair. So, we've got a number line. Most of the time it'll already be numbered for you, especially in Edge Elastic. I'll just number it myself. And Chloe, what kind of circle am I going to use in this one?
A closed circle.
Closed circle. And Ethan, what number is the closed circle going to go on? 2. And Chris, which way am I going to shade? To shade in the numbers that are greater than or equal to 2?
We're going to be shading towards the left.
So this would be the left?
Right.
Yeah, we want to shade to the right. Okay. Bigger is to the right.
I pointed that way and I said no.
That's okay. And that's it. That's one way to graph x is greater than or equal to 2. Questions on that? All right, let's look at this one. So this is example 2a. We could call this example 2b. How can we fix this so that it's set up letter, symbol, number? And remember, it has to stay pointing the same thing it was pointing at. It's pointing at the 2, pointing at the 2. So it should stay pointing at the same thing no matter how you write it. Yep, Ashley?
Y is less than 3.
Y is less than 3. Pointing at the Y, pointing at the Y. Perfect. So that's what you want. All right. There's lots of ways you can number your number line. I just put 0, 1, 2, 3, 4. However you want to number it is fine. Just make sure it goes up to the right and it goes down towards the left. How about Zach? What kind of circle on this one?
Open circle.
Yep, open. Tyler, can you tell me what number?
3.
Open on 3. And Sarah, which way would I shade?
To the left.
To the left, right? All the numbers that are less than 3. Less than numbers are to the left. And you can just do it right on the number line, just like that. That's fine. In Edge Elastic, I can help you with it, but you get a little tool you click on the bottom, and then you can click where you want to put it. And if you put it in the wrong spot, you can drag the circle to where you want it. And usually what it does is it'll automatically snap to the closest integer. So you can't accidentally put it at like 3.4. I usually try to make it come out to a nice number. Okay, questions on that? All right, so I'm going to look at the same 2 problems again. But what you're going to see in the book is they're not going to use a closed circle. In place of a closed circle, you can use a bracket. But you do it pretty much the same way. The only thing you've got to think of is the bracket should face the direction you're going to shade. So you kind of have to think of that ahead of time a little bit. So in this problem, we shaded to the right. So we look like this. Bracket on 2.
At this time, sophomore.
I don't really care which way you do it. I just want you to be familiar with this way. So if I gave you something like this on the test, and I said, write down an inequality that represents what's in this box, you would know that that means greater than or equal to 2. The letter you use, I mean, you could use X, you could use Y, you could really use any letter. Now, if you can use a bracket in place of the filled-in circle, anybody have a guess what you might be able to use in place of the open circle? Yeah.
Parentheses.
Yep, you can use a parenthesis. So, another way you can graph y is less than 3. Parenthesis on 3, but you got to think ahead. Which way are you going to shade? Because the parenthesis should open that way. Parenthesis on 3. Shade left. And there you go. Any question on the bracket and parenthesis? That might be new. I'm guessing a lot of people didn't know that. But I think that's probably the only new thing you'll see today. Okay, this is when you take 2 inequalities and combine them into one. This is called a conjunction. When you have an and, you can combine 2 statements into one. And if you look at it and you're like, well, wait, how do you get those 2 from there? There's 1. 2 is less than or equal to x. Those are exactly the same thing. We talked about how to rewrite it. And x is less than or equal to 9. Those boxes in blue are exactly the same thing. So you might see a problem on a test where it gives you a box that's a conjunction, and it may say break it down. So it's 2 separate statements. That's how you would break it down. Or you can take 2 separate statements and combine them together. The way I generally think to do it is you put the variable in the middle, the smaller number on the left, and the bigger number on the right. Could you do this? Is that the same thing? Is that the same thing?
Yeah.
Yeah, that's the same thing. Here is your x is greater than or equal to 2. That's the green box. And here is 9 is greater than or equal to x. 9 is greater than or equal to x. Yeah, same thing. So there are a couple ways, if I asked you to take two statements and combine them together, you can do it. But I generally do it this way. Smaller number on the left, bigger number on the right. That's up to you. So let's graph that. This is going to look a little bit different. It's not an arrow pointing in one direction this time. So let's start with the 2. Bailey, what kind of symbol could I put on the 2? I have a choice. Two things I could use. Could use a bracket, yeah. Or?
Oh, no, sorry, closer.
Closed circle. We could do either one. Let's stick with the circles. So I'm going to do a closed circle on 2. And Jake, what kind of, now that we've chosen that, we're going to stick with circles for the rest of the problem. We don't switch to brackets now, or parentheses. So we're sticking with circles. What kind of circle on 9?
Closed circle.
Closed circle. And Francesca, where do I shade?
Well, for the 2, you go to the right,
Mm-hmm.
and then for the 9, you go to the left.
Yeah, so where does that end up being?
In the middle.
In the middle, right? We're gonna shade between. We connect the dots. When you have an and, it's a between. It's not an arrow pointing in one direction. It's between. That's how you graph a conjunction. Any questions on that? Okay, so again, stuff you've probably seen back in Algebra 1, just haven't seen it for quite a while. All right, absolute value. How do you write, or what's the symbol for absolute value? Anyone remember what it looks like? Ethan?
2 straight lines.
Yeah, it's like 2 straight lines, like 2 bars. Looks kind of like that. So remember, absolute value, if you want to think about it geometrically, is the distance from 0. What kind of number is distance? It always has to be positive, or I guess it could be 0 too. Like the distance between the music stand and me is 0, because I'm touching it. So it's 0 distance. But it cannot be negative. So if I asked you, what's the absolute value of 6? Abigail, what's the absolute value of 6? 6. And Jack, what if I asked the absolute value of negative 3? 3. Any questions on that? All right. So, absolute value is how you can figure out how far apart two things are. So if I'm on a number line, and I want to know how far it is from point A to point B, just subtract A from B and take the absolute value. And that'll tell you how far apart they are. So A will be a number, B will also be a number, and then we'll subtract the 2 and take the absolute value. Now, does subtraction normally matter the order you do it in? Yeah, 5 minus 2 is different than 2 minus 5. But how about if you put absolute values around the subtraction? Yeah, then it doesn't matter. So technically you could do A minus B or B minus A. You might get the negative of your answer, but it doesn't matter because when you take absolute value, it becomes positive. So let's find the distance between these 2 points. Right, so Casey, if I was gonna find distance between these 2 points, can you fill those numbers into that formula above? And just tell me what I would write down.
-2 plus 9.
Yep, -2, go, keep going.
Minus 9 and 9.
Minus -9. Okay, anything else?
Oh, and the absolute value.
Yeah, we want to put those absolute value bars, even though the order that Casey gave it to me in, it's not going to make a difference. Because -2 minus -9. Isaac, what happens when you minus a minus?
Turns it into a plus.
Turns it into a plus. So by doing that, it's actually going to make what's inside positive anyway. So the distance between -2 and -9 is 7 units. Okay, questions on that? All right, next thing. So we talked a little bit about one-dimensional coordinate system, like a number line. Now we're going to talk about 2D. Let's see if we can just name some of the things that are important first. So you have 2 axes. Anyone remember the name of the horizontal? Yeah, Chris?
The x-axis.
X-axis. And the vertical? What do we call that one, Jack?
Y-axis.
Y-axis. The 2 axes divide the plane and make a plus sign. They divide it into 4 areas. Anyone remember what you call those 4 sections? They're not really called sections. Jake?
The quadrants.
Quadrants. Yep. On the x-axis, which direction? We already talked about it, but which direction do the positive numbers go in for the x-axis? Yeah.
Right.
The right? How about for the y-axis? Which direction are the positive numbers? Tyler? Up. Where the axes cross is origin. Forgot to mention that. But I think we mentioned everything else. X and y axis. Quadrants are numbered in Roman numerals. 1 is in the upper right. 2, 3, 4 going counterclockwise. I've labeled what a... Well, actually, you tell me, what is this thing called? Parentheses, 2 numbers separated with a comma. Yeah.
It's a coordinate pair.
It's a coordinate. Or if you want to be more specific, it's an ordered pair. If we were doing 3D, it would be an ordered triple. So I've labeled what kind of coordinates you'll find in each quadrant. Quadrant 1, you'll find positive x and y values. Quadrant 2, negative x's, positive y's, and so on. Again, we normally won't cover this many different topics in a day, but this is really all kind of Algebra 1 basic review stuff. I already asked you that. So xy, that's called a coordinate. But more specifically, in 2D, an ordered pair. I got 2 slides left. Okay, the next thing we're going to look at does involve the graphing calculator. So I'm going to show you guys how to do something on that. Okay, the biggest thing with the graphing calculator is I need people to be patient. You may be perfectly fine with it and understand everything, but there might be somebody really struggling with how to figure something out. But just keep in mind that could be you. All right, so just be patient while I'm trying to get everyone on the same page with the calculator. So one of the things we're going to do a lot on the calculator is we're going to have to zoom. The calculator will do whatever you tell it, but it's only as smart, it's only as useful as the person that knows how to use it. You can hand somebody all the equipment to do MIG welding. If they don't know how to do it, that equipment's not going to help them much. You have to know how to use what tool you're given. So that's one of the things we're going to learn today is the zooming. So let's all try something. So you want to turn your calculator on. The on button is in the lower left. When you turn it on, you should be at a screen like this. If you're at some other screen, you can press the blue button, the second button, and then mode. That's quit. Second, quit. And it should bring you back to that main screen. If there's something on the main screen that the person before you did on it, you can always press clear, and it'll get rid of anything that's on the screen. Is anybody not at a screen that looks like that? All right, so what we're going to do is we're going to go press this button in the upper left that says y equals. And when you do that, you should get a screen that lets you type in, it says y1 through y9. So those are all different equations we can type in. We're just going to use one of them. What I want to type in first is press the button right below mode. It says x, comma t, comma theta, comma n. So if you press that button, it's in the second column, and it's the second button down. You should have an x on the screen. Now I want to put in an exponent of 2. There's a couple ways you can do it, but I'm going to press the button that's 4 down from the, actually 5 down, 1, 2, 3. It's in the 5th row, the x squared button. Okay, that'll put in an exponent of 2. Then I'm going to press plus, and I'm going to type in 10. So everyone's screen should look like that. X squared plus 10. Okay, any question on getting to that stuff? All right, now we're going to hit graph. When you hit graph, you're going to see a little yellow circle in the upper right spinning. That means the calculator is doing something. And when it stops, it's done. Now, some of you may see something on the screen, some of you may not. I don't know, it depends. How many people didn't get anything on the screen? All right, let's press zoom, and let's press 6. Zoom 6.
It says error invalid dimension.
It says error, okay. So let's press y equals. And I bet that your screen looks like that. Plot 1 is highlighted. Am I correct? So you want it to look like that. So none of the plots are highlighted. If one of them is, press the up arrow and it should start blinking. When you're on the one you want to change, hit enter. And now, if you press the down arrow again, none of the plots should be highlighted. Yes?
My screen just says invalid dimension.
All right, so you have to press 1, and that'll, I think 1 says to quit. So you want to quit out of that screen. And now you can go to y equals and turn off plot 1. Anyone else that's still having trouble with that plot 1 being on? Okay, so now press zoom 6. Zoom 6 does what's called a standard window. The standard window on a graphing calculator is from -10 to 10 on the x-axis and -10 to 10 on the y-axis. That's the normal location that it'll set. So press zoom 6. And now, if you had something on the screen, you probably don't anymore. Yes?
I'm just lost. So I'm stuck on the Y screen.
Yep.
I need to turn off plot 1 when you do that.
So you want to go up to plot 1 and then hit enter. I have to hit it again because I just turned it back on. But now when you hit graph, it shouldn't say invalid dimensions anymore. Did it? Still saying it, or you're good? Good, okay. So there is a graph there. How come I can't see it? Anyone have a guess why? Yeah.
The line is already going above the 10 mark, which is the standard.
Yeah, the graph is up higher. So what we're going to do is we're going to set the window on our calculator so that we can see more. Okay, we're going to set the window bigger. When you see a problem in the homework that says set your window or set your calculator with a viewing window, that's just a question to practice on a calculator. There's not really any arithmetic or something to do on paper. It's just a calculator question. So nothing to show on paper. But when you see a window given like that, the first two numbers are your x values, your min and a max. And the second two numbers are y values, min and max. Those are the four numbers that you need to set our viewing rectangle, or it's also called a window. So, on your calculator, there's a button that says window. It's at the top. It's right next to y equals. Then I've pressed the window button. Now you have some different things you can type in. You have an x min, an x max, and we're going to do the y min and the y max. It's important when you type in a negative number that you use the symbol that's below the 3 and right next to the decimal. That's the negative sign for a number. The negative button on the right-hand side, that's to do a subtraction problem. And so they're different. So to type in a negative number, press the one next to the decimal, put in 20, and then hit enter. X max, positive 20, hit enter. Y min, negative 20, Y max, positive 20. So now your screen should look just like that. And I never really noticed it, I guess I didn't pay attention to it, but there's actually a little description right here that tells you what each one does. So I'm highlighted on Y scale, and if you're wondering what does Y scale do, you didn't really, or maybe you didn't even know SC element scale. It tells you up at the top the distance between the tick marks on the axis. So it changes how often you see a tick mark. If you want to see a tick mark every 1 unit, you want to see a tick mark every 2 units, how often do you want to see tick marks on your screen? So it's kind of handy. It doesn't do that for the X min and the X max. I guess that's self-explanatory what that is. Now, tick graph. Now, everyone should see that graph on their screen. Okay, how many people got that graph? Okay, good. So the reason we couldn't see it before is because the window was basically right there. We had to zoom out. All right, so any questions on setting a window? Don't worry about changing the X scale and the Y scale. I can show you what happens. It's not something I ever really play with. But now you can see on the x-axis, I don't have as many tick marks as I did before because I set the scale on 5 instead of 1. We don't really play with the scale at all. All right. And last slide. So, last thing we're going to look at is what's called the distance and the midpoint formula. So this formula is basically a way, and this applies to now XY axes, that's kind of what we're studying right now. It gives you a way to find out how far apart 2 points are, as long as you know the coordinates for them, or the ordered pairs. So that is what we call the distance formula. And it is based on the Pythagorean theorem. It is the Pythagorean theorem. You square something, you add them up, and you take the square root. That's exactly what the Pythagorean theorem is. So this formula has 5 variables in it. If you're like 5, I only see 4. Yes, there's 4 on the right, and then the variable you're solving for on the left is the distance. So out of those 5 variables, you will always be given 4 of them. Could be the 4 on the right, or they could give you a problem that says the distance between 2 points is 5 units. I'll tell you one of the coordinates, and you have to figure out part of the other coordinate, knowing how far away the coordinate is. Okay, so they could give you the distance instead of both coordinates. But let's try one where I give you coordinates. So let's find the distance between 1, 4 and 5, 6. And I don't do this all the time, but we'll just do it for the first time. Let's label each one of these numbers based on which one of the 4 variables it is. Let's start with the number 1. You actually have a choice. What could we label the number 1 as? Yeah?
X1.
X1 or
X2.
X2. Right now it could be either one. Once we decide what we want it to be, then everything else only has one name. There's no other choices. Let's call it X1. So it's X1. What does that mean the 4 has to be? Yep. Has to be Y1. Which means the 5 is X2 and the 6 is Y2. So plug those 4 numbers into those 4 spots and see what your distance is. Okay, this is just my habit. Whenever I do the distance formula, I do this first. There's a lot of parentheses and symbols in it, so I like to write them all down first. Zach, what did you fill in for our first set of parentheses?
First step would be 1 minus 5.
Yep. So we got 1 minus 5. And Isaac, what did you fill in for the second set?
4 minus 6.
Good. So we'll do that out. 1 minus 5 gives me negative 4. And Francesca, what's negative 4 squared? 16, yep. And Matt, 4 minus 6 gives me
Negative 2.
and to the second power?
4.
4. So that comes out to the square root of 20. But what does the square root of 20 simplify to? What does that reduce to?
I don't know how to word it, but it's the 2 and then the square root of 5.
Yes, 2 square roots of 5. So that's, again, that's an algebra 1 thing. That you always want to simplify a square root as much as you can. Some people make like a tree, like a factor tree to do that. When I simplify the square root of 20, the way I do it is I factor the number 20. And I factor it this. 4 times 5 is 20. I try to factor it so that one of the numbers comes out nice when I take the square root. So I try to use like a 4, a 9, a 16, a 25, something like that. Okay, those are perfect squares. So 4 times 5 gives you 20. Square root of 4, 2. That's how you get that. Okay, so that's the distance formula. And the last formula, midpoint formula. So the distance formula tells you how far apart 2 points are. The midpoint formula gives you a location in the middle of 2 points. Now, if you had 2 test scores, like a 75 and an 85, and I had to give you a grade for the term, what do we call the number that's in the middle Like what would I give you? It would be your what of the 75 and 85? It's
It's the average.
the average. That's exactly what the midpoint formula is. It's an average. How do you average two numbers in math? What's the steps? Yep.
Add together and then divide by 2.
Add them
Or,
together and then
divide
divide by 2 if you're averaging two numbers. So to find the coordinates of the midpoint, you add the x's together and divide by 2. So it's the average of the x values. And then add the y's and divide by 2. So it's the average of the y's. So I'll give you guys a couple seconds to write that down, and then we will finish up with an example of midpoint. Everyone okay if I scroll up a little bit? So, find the midpoint between -5, 2 and 3, 7. You gotta be careful, because when you're doing the midpoint formula, it has a plus. When you're doing the distance formula, where is it? It has a minus. So people mix that up. All right, so add the x's up and divide by 2. -5, +3. There's my x's. Y values, 2 and 7. All right, Abigail, what is -5 plus 3?
-2.
And if you divide that by 2?
1.
-1, yeah. So -1. 2 plus 7 is 9. 9 divided by 2. You can either leave it as 9 divided by 2, like on Edge Elastic, that would be marked correct, or you could put in 4.5. That would also be fine. I'm just going to leave it as 9 over 2. Okay, so that's the midpoint. All right, so we covered a bunch of different topics. I'm going to guess most of that was, maybe you didn't remember like the distance or midpoint formula, but I'm sure you covered it at some point. But maybe that bracket in parentheses, that might have been the only new thing. All right, so that's the homework for tonight. Okay, on page 11. (5 through 16). 20 to 23, and then 28, 31, 32, and 44. Remember tomorrow, I think they did have sophomores come to class before the assembly, so my guess is you'll come here, and then we'll go down. But if we come back and there's only a half hour of class left, we'll probably just go over the homework. If there's like an hour of class left, then we'll probably do the next lesson. Either way.